8.3, we're still dealing with energy, but we're going to be a little bit more specific here and talk about what is work. All right, so work is not just what you're doing at your desk right now. Okay, that's not the work we're talking about. Work is the transfer of energy. Transfer of energy that occurs when a force makes an object move. A transfer of energy that when you have a force makes an object move. There is no work unless an object moves. Okay, that's going to be the key thing there. An object has to move in order for work to happen. So here we go. To do work. I'm going to give you different scenarios. You have to tell me whether the person is working or not. All right, so first, a force has to be applied. Some force has to be applied. So this girl here is lifting the books. So in order to lift the books, she first is putting a force on them to go up, right? And the motion has to be in the same direction. So since she's pulling up on it, the books are also moving up. I'm sorry. So since she's pushing or pulling, since she's pulling the books up, the books are also moving up. Therefore, she is doing work. Another scenario, let me draw my little stick figure here. Let's say this person here. This person is holding weights above his head. He's just holding weights, just holding them there. His muscles are going to get tired, okay? But himself is not doing any work because all he's doing is holding it above his head. There is no motion, therefore no work. So no motion. No motion means no work. No motion, no work. And it has to be in the same direction. So another scenario is you carrying your book bag down the hallway. It's on your back. It might hurt your back a little bit because your back is holding it up, but the book bag is moving left or right, correct? Or forwards and backwards. It's not going up and down. Therefore, you're not doing any work. Okay? You yourself, your muscles and everything that we can get a little bit more detailed, but you are not doing any work. Of course, there's a formula. So here we go. W equals FD. Remember that the force must be in the same direction in order for work to happen. So let's talk about what's going on. Just don't worry about that right now. I'll just rewrite it here. So W stands for work. F stands for force. We've dealt with this already. D stands for distance, on how far you move. Okay, so this is your formula. This is what the letters stand for. So W work, F force, D distance. Units. Work is what's going to be called joules. Joules, however you want to pronounce it. It's written by the letter just J. Force, we've already dealt with, is newtons. Distance is going to be in meters. Okay, again, important to know what the letters mean and your units. And then to finish with our lovely triangle here, so F and D are already multiplying. So F and D go together with W on top. So let's do an example here. We'll keep this so we got it for us. So Jessica applies a force of 2 newtons. So you got those newtons sitting there, right? So you should know that newtons is force, so that's F, and moves the book 1.5 meters high. So therefore that's going to be our distance and how much work was done. Okay, so this is our thing here. We're looking for W. So W is just simply equals FD. So you're going to do 2 times 1.5. So 2 times 1.5 and you get 3 joules. Done. Okay, it's that easy. Don't make it any harder than what it is. All right, so let's talk about this. A 10 kilogram object accelerates. All right, we got accelerates at 5 meters per second squared and moves 20 meters. How much work is done by the force? So this one's a little bit tricky. So I'm going to slow it down just a notch. All right, so let's label what we have. Let's label. So 10 kilograms. You need to look at every little letter. Kilograms. Wait, we haven't talked about kilograms this video. What the heck is kilograms? That, remember, is mass. That is M. So you're going to label that as M. Accelerates 5 meters per second squared. That's another unit. We have not talked about this video, but we have. You cannot forget information in this class. You've got to remember that meters per second squared is acceleration. And moves 20 meters. Meters is distance. How much work, so you're looking for W, is done by the force. All right, so remember that work equals force times distance. Do you have force? You do not have force. So this is actually a two-step problem, all right? If you do not have enough information to solve for the variable that you're looking for, you need to look at what do I need to find this variable. So we have the D, but we're missing F. How? F. Now I am helping you here. Remember, F equals ma, so you got to look back at formulas we've already used in order to solve this problem. So you've got to remember that F equals ma. So that's our first step, is to find F. Okay, so you're going to do 10 times 5, which gives you 50 newtons. Okay, and then since we have force now, this is our F, now we have force and distance. So we can plug it into our equation. So you can do 50 times 20, which gives you can't do math in my head today. Yeah, 1,000. Of course, here. Okay, so 50 times 20 gives you 1,000 joules. Done. Okay, so you need to be ready for simple ones and then harder ones. But a lot of times, if it looks like you don't have the information you need, step one is going to be to solve for force first and then go into the work equation.